put again. For part A, M is what? 700. And that's going to be easy in the differential form as long as it's 700 minus P and not 700 times, 700 minus a number with a coefficient there. I can't remember if they throw one of those at you, but if they do, you got a little more work to do. As long as it's a number minus B, that number is M every time. All right, then B asks for the size of the population when it's growing the fastest. Well, if you think about a logistic curve, there is odd symmetry around its center. Okay? So I'm asking you to think about looking at the graph. Where would the slope be the steepest? At that center point, right? Which is where? Think about your horizontal asymptotes. Where is that going to be? It's going to be where? No, you didn't. Clearly, we aren't in the part B mode. Where is the population growing the fastest? Because the equation is the growth. Yes, because it's halfway between 0 and 700. Thank you. Woo, Dalton, you can do some math, man. I mean, literally 3 of y'all got to the point where you were thought you were about to say 350, and then you were like trailing off. I'm like, what are you doing? You walked up to the answers. No, I think I'll go do something else. That's what I told you. I told you this one was easy. All right? Oh my God. And then C says the rate at which the population is growing when it is growing fastest. Now, that's the only part that might make you think a little bit. What is the rate in this equation? You were thinking too hard. Once again, like 5 of you were saying the right thing and then you quit. It's the derivative. The derivative is the rate. Oh my God. And I wonder why you don't know log properties. Okay, what does the derivative tell me? The rate at which population is changing with respect to, yes.
Maybe we should need to put there on a good note.
Is that good enough? I'm not thinking so.
Well, on the best note.
All right. So basically what I'm going to do is figure out what dp dt is at that time. Okay? So we're going to keep that lovely decimal. And what's the p at which we're interested in the rate? Thank you. And then we have 700 minus that p, so we get 350. Grab a calculator and figure out what that is. It's just that simple. What is it? 98. This equals 98. Now, let's put some units on these answers, okay? Now, they didn't tell us this was a population of bears or elves or unicorns or otters. It didn't say people. So, if you had to, okay, you could say units, but that would be ultra clinical. Let's say individuals. All right? And so the individuals would be the units for, that's the actual units for parts A and B, isn't it? Because it said, what is the population? There are 700 individuals. There are 350 individuals when the rate is growing the fastest. And for part C, then that tells us that our rate is individuals per year.
But they don't give us any units. Do you have to individuals?
No, but typically you'll have units. I mean, on the AP exam, you're going to have individuals. I mean, you're going to have you don't know what the individuals are. It'll be cows or horses or squirrels or rabbits, bass, goldfish, Matthews. All right.
I was thinking more the.
I'm about to get. God, Lord save us all.
Lightsabers grow at a population rate.
They do in Star Wars. I've never seen Star Wars.
Yeah, exactly.
For what?
Well, you know what? You didn't need to say, I haven't seen Star Wars, if you said they do in Star Wars. Because no, they don't. Either you don't know what a growth rate is, or you haven't seen Star Wars. It's the only two possible reasonable explanations for that. I don't know about y'all, but I'm getting tired of writing the same freaking equation, and it's not T, it's P.
The short way?
Yes.
Yeah.
The short way after we've written this freaking equation, what, like 12 times now? So tired of it. I'm so ready to move on.
This is the short way, right?
Yes, yes.
Will the short way always work, or is it?
Yes. The short way will always work. The danger, the risk you run into in jumping straight to the shortcut, which is why you couldn't do derivatives until you understood the definition of a derivative, is that if all you know is the short way, you're still in memorizing mode. You can't memorize your way through college. You can't memorize your way into being prepared for the AP exam. Somewhere in this room, probably a male is saying, I bet I can. And he's going to get a 1, or worse, a 2. To me, that's the worst score. You know, because a 2 means maybe, just maybe if I've gotten one more question right, I'd have had a 3, a.k.a. credit for the class. All right, so here's my equation. We're going to do this the short way. Oh, I don't know where I got that either. Heck, I just need to go home and go back to bed because I was sleeping so hard. I didn't get as much sleep as I needed, but I got the best night I've had all week. All right.
When I woke up, it felt like the second task.
Oh, yeah. Yeah, that's when you know. When you feel like you just fell asleep, and then when you have that thought go through your head, you realize you can't move your body at first because you haven't moved in so long. It's like, ooh. There's no feeling in your left arm. You think somebody's cut it off while you slept or something.
I slept like this, and like right here was like asleep, not my arm.
Yeah.
Just like my elbow part. Was like, so weird.
You're so talented, Virginia.
Well, I don't understand how that happens.
Okay, you probably had some sort of nerve compressed while you slept. All right, here we go. Short way. You won't appreciate the short way until you endured what we did with the long way before we started the video. And for anyone watching the video who's not present today, come see me and I'll go through the long way with you guys if you want to. All right? I think I am going to go be a college professor after I get my degree. I think I am, because I can't wait till the day I can look at somebody and say, get out, and don't come back. It would make my life, because there's been a billion times in my career where I wanted to say that to somebody and I couldn't. All right, not a billion, that would be exaggerating. So anyway, here's what we're going to do. We're going to use our knowledge that we just applied in the last one. And the reason these authors one of the things I like about this textbook is they do recycle equations. Because if you've thought through something on a simpler equation, they allow you to apply that on a more complex equation so that you can understand the power of what you know, all right, without having to rethink it every time. All right, so here we have the same equation, same numbers, right? But what becomes really important if I have to write my P of T equation is that I know what K is, that I know what M is, and that I know what A is, right? Y'all with me? Because now we're looking at and I'll tell you what page it's on, and it should be in your notes from yesterday, the general logistic formula box at the bottom of page 371. That's what we're going for. So if you look at that P equation, we're going to need M, we're going to need A, and we're going to need K. You with me? So now you know what I was talking about when I said that, because some of you are just nodding, and I could tell you had no idea what I was talking about. All right, so what do we already know about this equation? We know M is 700. And do we know K? We just haven't used it. I just wondered if y'all actually knew it or you were just saying that because that's what some of y'all seem to be doing this morning. All right, there's my K, right? All right, and again, always be careful about just grabbing that number though, because if there's a coefficient on P, you have work to do. And I feel like they're going to do that to you at some point. I can't remember if it's in here or in the pre-cal book that they do that. All right, so we've got our M and our K. So what does that mean we need? We need A. All right. Now, remember, I actually mentioned A yesterday as we recorded the contents of that box in your notes, and I said A is not what it is in exponential land. What would the coefficient of a E thing in exponential land be? Your initial population or value, whatever you're dealing with, right? But here, it's not. It's a constant that we have to find, all right? So what we're going to do is we're going to take the initial condition that we were given, where P is 10 when T is 0, and so we're going to write P of 0 equals 10. Not 10. What was my population? Yeah, it was 10. Oh, I just wrote 10 twice a while ago. I remember writing 10 when I wasn't supposed to. All right, P of 0 equals 10 equals, what's my M? So I put the 700 on the top over 1 plus, big A is what we're after. So you're always going to put that big A there, okay? Resist the urge to put anything else there. All right, E to the negative, and then what's next in the box? Because it's MK, right? That's the coefficient of T is the product of M and K. So let's write those in there. So it is 700 times 0.0008 T times 0. Oh, wait, yes, you're right. I forgot we were plugging the condition in. Sorry. I was thinking about having to make that bar that long instead of thinking about writing my 0. Which is fabulous news, right? Now, I could tell you just to go ahead and make that exponent 0, but I think it's good here to remind yourself that you have to account for everything in there. Obviously, if you're plugging in 0, your exponent is going to be 0. Why is that good news? Because that gives us 10 equals 700 over 1 plus A. Right? All right, well, there's a couple different, basically, so now solve for A. I'm going to let you do whatever you do to solve for A. And then I'm going to show you how I solve for A. I actually showed you this last year, but we'll see if you remember. And I want you to do whatever comes naturally, because then when I show you this way, I want you to see the power of what I'm showing you. Well, of course it's going to be. You already know the answer. We already did it, Matthew.
Oh.
I'm calling your stepfather today. Isn't your stepfather a minister?
Maybe.
I'm going to call him and I'm going to act so naive and I'm going to be like, maybe you could explain to me why he thinks the number 69 is so fascinating and of interest and makes him giggle like a silly little 3-year-old. Maybe he could explain it to you, because I couldn't get him to explain it to me. Y'all ready for me to show you the smart way to do this problem?
Yes, please.
All right. If I divide 700 by something and I get 10, what am I dividing by? I mean, what am I, 70. So that means that the denominator has to equal 70. And that's a terrible plus sign. Which means that A is what we discovered earlier. And I really even hate to say the number again, so I'm just going to write it. Because we have 12-year-olds in the corner whose ringleader is a 3-year-old. Okay, look. No, okay, instead of doing all this terrible waste of time doing algebra, just because doesn't this just say 700 divided by something is 10? What would I divide 700 by and get 10? Isn't that the smart way to do that problem? That's where you want to get to. All right, so then we're going to end up with the same final equation that we did, doing it the long, drawn-out way. P of T equals 700 over 1 plus that number again, E to the negative. Now, what's 0.0008 times 700? 0.56. So that's what we're going to put here instead of multiplying that out in this notation. So that's my equation. It's still a little bit of work, but rather than make you whine about this amount of work, I thought I'd show you what your alternative is. You like this one better? Yeah, me too. All right. So that takes care of 24 and 28. And in fact, I think that gets you far enough that you should be able to go from here.